Vector component. Vector components are very important in physics and it has two basic features that are apparent in the figure. One is that the components add together is equal to the original vector. That is vector r, which is the displacement from starting to finish, is equal to vector x plus vector y. These two components indicates how the finish point is displaced relative to the starting point. That means x, vector x, or the x component represent the displacement of vector r at the horizon, while vector y, or y component, represent the displacement at vertical. Another feature of vector component is that x and y component are perpendicular vector. That means that the trigonometric functions are applicable in analyzing vector. Any type of vector may be expressed in terms of its components. And they add vectorially to equal the original vector. Let's have an example. A displacement vector has a magnitude of 175 meters and points at an angle of 50 degrees relative to the x-axis. Find the x and y component of this vector. So we have given r, which is equal to the magnitude 175 meter. And we are looking for the magnitude of x component and the magnitude of y component. As I have said, to solve for x and y component, we are going to use trigonometric function. Based on the figure, the right triangle, 50 degrees, has an opposite side, which is the y component, and the adjacent side is the x component. To solve for x and y component, x component is equal to r cosine theta, wherein cosine theta, as we have discussed earlier, is equal to the adjacent side over the hypotenuse. Therefore, in the figure, in this problem, cosine theta is equal to x over r. Now, let's substitute the value of r and theta. We have x is equal to r is 175 meter times cosine 50 degrees. Therefore, x component is equal to 112.49 meter. We don't have to solve for the direction since it is x component. We know that it is directed or along the horizon. Now, to solve for y component, again, using trigonometric function, we can see that sine theta is equal to the opposite side, which is the y component over the hypotenuse r. And using the trigonometric function, y is equal to r sine theta. Let's substitute the value. So we have y is equal to 175 meter times sine 50 degrees. Therefore, y component is equal to 134.06 meter. Now, let's check your understanding. Our displacement vector is 23 km in length and directed 65 degrees south of east. What are the components of this vector? Again, your answer must be posted in the comment section of this video.